Hello friends, welcome once again to my YouTube channel. It is still your teacher Peter Ekaja, and I am going to be taking you through definite integrals and change of limits. This is basically going to be the continuation of our previous tutorial, which was talking about the method of change of variables. Now it is important for us to also appreciate that actually the method of change of variables is still applicable here, only that this time round, because we're talking about changing limits, we shall find it more convenient for us to also change limits at the same time immediately after changing the variable. Now maybe before we proceed ahead, we need to first understand what we mean by definite integrals. For an integral to be definite, it must be having its limits clearly defined. That means the integral must have the lower limit and the upper limit clearly stated. Without wasting a lot of time, we shall begin with our examples here. And question 1 says, evaluate integral from a half to 3x root of 2x plus 3 with respect to x. What would we do in such a case if we made such a question? Now, since we said we are going to use the change of variable technique, as you can see, we must then have to ask ourselves whether we are introducing a new variable and we are calling either the entire square root and its content as we see here, or we only take what is within the square root. Now actually there are two options. You can either take the entire square root with its content, or you only take 2x plus 3. Any of the two options will give you the same answer at the end of it all. So for now, what we are going to do is to look at a situation whereby I let u, which is my new variable, to be the entire square root with its content. Let's look at that. So I will say in my solution, I will let u to be root of 2x plus 3. Now if u is root of 2x plus 3, to remove the square root we can simply square both sides. So it means I can square both sides so that I have u squared is equals to 2x plus 3. Then from this point we now have to differentiate u squared with respect to x, and that must give us 2u du dx, giving us 2 on the right hand side. When you differentiate 2x plus 3 with respect to x, you get 2. If you can easily look at this, the 2 can cancel with the 2, so that now when we make the x the subject, it actually becomes u du. Now that we have reached this stage, it means we have changed the variable. That means it also becomes important for us to change the limits. How do we change limits? Now, to change limits, I'm going to draw a simple table here. I'll draw a simple table. We have a simple table here. And this table will have the old limits and the new limits. So we have x. Sorry for that. Okay. We shall have limits of x and then limits of u, where u is the new variable we have just introduced. So it means I will have here x, and the limits of x, if you remember from our previous question, from our first question, when you get back there, the lower limit was a half and the upper limit was 3. That means I will now say our limits of x are going to be a half and then 3. Then we have our new variable, which is u, and now we are going to look for the limits of u. How do we do so? I simply go back, substitute the values of x in this equation that relates u and x. So where there is x, I put a half. That will be 2 by a half, which is 1 plus 3. That means we get a 4. Square root of 4, we shall take a positive root, which is 2. Then put a 3 also to get the value of u again, put a 3 here where there is x. That means I'll have 2 by 3 plus 3, which gives me 9. But take a square root of 9, you still get a 3. So I will also take that. So the limits of u are 2 to 3. That means I will now say integral of x root of 2x plus 3 with respect to x is now going to become integral. Now remember, you've changed the variable completely, and this x does not cancel yet. That means we come back to this expression here. You make x the subject. Indeed, when you make x the subject from this expression, x becomes u squared minus 3, but all divided by what? Divided by 2. So in the place of x here, I will put u squared minus 3, all this divided by 2. But remember, all this you are multiplying it by the square root of 2x plus 3, which you called to be u at the beginning here. We called it to be u, so I will have a u there. Then the dx now changed to u du. That means I have another u here, du. If you look at this carefully, you shall have a half out because it is constant. Then we shall have u power 4 minus 3u squared. Why do I have u power 4? U by u is u squared, multiplied by u squared, you get u power 4. U by u is still u squared, multiplied by 3, you get 3u squared. That means our next step will be equals to integral, a half, we pulled out a half, into brackets u power 4 minus 3u squared. And we're integrating all these with respect to u, but remember the new limits are now 2 to 3. This must clearly be captured even in our very first step here, where we're changing limits now from a half to 3, then now to 2, then to 3. So you see, we are now clearly showing that we have moved away from x with its limits. We have gone to u, but with the new limits of u. That is what we mean by changing the limit. Now, from there, we can now continue and integrate. So we shall have a half. If you integrate u power 4, you get u power 5. U power 5 divided by 5 minus, if you integrate 3u squared, you will get u cubed. Why? Because it would be u cubed divided by 3, but there is this 3 here which cancels out. So all this, we have our limits from 2 to what? 2 to 3. Then now you can comfortably substitute your limits so that you now have a half out, curl brackets. This is now 3 power 5 out of 5 minus 3 cubed. All this minus, you now substitute the lower limit, 2 power 5 out of 5, and then minus 2 power 3. So all this, when you press it carefully from your calculator, we can actually realize that the answer will be 11.6. So it means when you integrate from a half, to 3x root of 2x plus 3 with respect to x, you actually get 11.6. You can try out that and make sure you press the calculator carefully. So we can now say that is our answer for that. Question 2, we shall say our question 2, I will say evaluate integral from 2 to 3 x out of square root of x squared minus 3 with respect to x. They want us to evaluate that. In fact, before we look at this, I should remind you guys that when you get back to this question 1 that we just had, when you get back to question 1, someone would as well let u to be 2x plus 3. You would as well let u to be 2x plus 3 in our first question instead of taking the entire square root. At the end of the day, the answers will still be the same. Of course, when you change the limits will be a little bit different, but at the end of it all, after substituting, the answer will still be 11.6. Okay, now when we look at number 2, you're going to realize that to some extent a function exists with its derivative. Why? Because when I differentiate x squared minus 3, I will get 2x, which contains the element of x that we have here. So it means the x can now cancel out. So it means the best option here would actually be only taking what is within the square root. We call it our new variable, for example, u. So I will call this our u. Now, if I call that u, then it means my du dx will be 2x. So let's do that. Let's do that. So I will say in our solution, we had our integral z. We're integrating from 2 to 3, and we had x out of square root of x squared minus 3 with respect to x. So we are going to let, I'm again going to use my u to be x squared minus 3. That means the u dx, is equals to 2x. I make dx the subject, so dx becomes du out of 2x. Now at this level again, we have decided to move away from the x to the u. That means we automatically have to bring in the change of limits. We have to bring in the change of limits. So I will draw a simple table again. I will draw a simple table again for our change of limits. Simple table for change of limits. We have that. We have, yes, I think that will be enough for us. So now our previous limits that we had were limits of x. Now we are going to look for limits of u. Previous limits we had a 2 and a 3. Now a 2, which is the lower limit of x, now we go back here and substitute it here. So it will be 2 squared, substitute it here, it will be 2 squared minus 3, which gives us a 1. Then get a 3, substitute it also here. It means it will be 3 squared, which is 9, minus 3, which is 6. Minus 3, which is 6. So our new limits are going to be from 1 to 6. So we shall now say integral from 2 to 3 of x divided by square root of x squared minus 3 with respect to x is equal to integral. Now the limits have changed from 1 to 6, and then x, we know it's going to cancel because of these 2x here that you see. So I will have x there out of square root. Remember, I called the x squared minus 3 to be u. So I will have u there. The x became the u out of 2 what? Out of 2x. So the x now, we can easily see that x can go with x. So that will remain with integral from 1 to 6. Integral from 1 to 6. I can also see 1 out of 2 root u, but with respect to u. So 1 over 2 being a constant can come out of the integral sign, so that we have integral of 1 out of square root of u. So it means the next step will be 1 out of 2 integral from 1 to 6 1 out of square root of u with respect to u. Now when you do that, it is as good as saying now a half integral from 1 to 6. Now 1 over u under square root is as good as u power negative a half with respect to u. We integrate. How do you integrate that? Increase the power by 1, divide by the new power. So we shall have a half here. Then this will be u. We increase negative a half by 1. That will be power half. But you have to divide by a half. Now dividing by a half is as good as multiplying by the reciprocal. So I will have a 2 here. I will have a 2 there. Of course it will be 2 over 1, which is the same as 2. So the limits are 1 to 6. And these are limits of u, remember. So it means now this 2 being a constant can also come out and cancel with this. No problem with that. So that will remain with the u power half with our limits 1 to 6. And of course when you substitute the limits, that will be u 6 power half minus 1 power half. And that can be written as root of 6 minus 1, or you can write your answer to at least 4 decimal places unless instructed otherwise. So we can now make a conclusion that indeed integral from 2 to 3 of x out of the square root of x squared minus 3 with respect to x is equals to root 6 minus what? Minus 1. And that is indeed our answer. That is indeed our answer. So that is it. And this is how easy these questions are. Let's move on and now introduce trigonometrical functions. We also see how we can proceed with the same approach. Okay. Now, for trigonometrical functions, let me give a number like this. This is question 3. Evaluate integral from 0 to pi out of 4, cos cubed of x, then sine of x with respect to x. Good. Now in such a case, when you look at this carefully from the knowledge of change of variables, we can again realize that now because cos x is having a cube, or it has power 3, it would be better when we make a choice of letting our new variable to be cos. However much when you differentiate cos, you get negative sign, but again it will help us cancel out the sign here, other than taking sine. Because if you let u to be sine, for example, it cannot cancel the cos cubed. So we will prefer this term that has a power of 3. But we shall only let u to be cos of x. So that now when we differentiate it, the u dx becomes negative sine x. Automatically we make the x the subject, so it becomes the u out of negative sine of what? Sine of x. And when you have done this, it now means that we can go back and now think of changing limits. Why? Because we have moved from the respect of integration x to another respect of integration u. So we shall now change the limits. So we draw that simple table of ours. Draw that simple table. There we are. There we are. So we have that. We have that. Then we have that. So now all the limits were for x. Now we are bringing in u. X had limits 0, then this is pi out of what? Pi out of 4. So the lower limit for x is 0, so I substitute it here where there is x. put that means u becomes cos of 0. Cos of 0 is automatically 1. When you press your calculator, it is automatically 1. Then you put pi over 4 also in this same position of x to get u. That will give you 1 over root what? 1 over root 2. Yeah, we prefer taking this in third form just to make sure it is more accurate. Or you could take root 2 out of 2. It is the same as 1 over root 2. Now after changing the limits, we can now proceed and say, we can now proceed to the next page and say, let's proceed and say now that this is now going to be equals to, this is now going to be equals to integral, let us begin from what we really had. We had integral from 0 to pi out of 4. We had cos cubed of x sine x with respect to x is equals, now we have changed the limits, remember, so it is going to be from 1 to 1 over root 2, 1 to 1 over root 2 u cubed. Why? Because we called cos of x to be u. Now it will be u cubed. Sine x will remain there temporarily because it is going off in just a second. Dx became negative du out of sine x from our first steps of differentiation. So now sine x can help us cancel with sine x, so that we now have a negative out, integral from 1 to 1 out of root 2. What are we integrating? We are integrating u cubed with respect to u. The negative that we had here is already out here. So at the end of the day, we shall have a negative square bracket. This is u power 4 divided by 4. What have we done here? We have increased the power by 1 divided by the new power. From 1 to 1 out of root 2. And because these are limits of u, you substitute direct. So now it means we shall have a negative out, curl bracket, 1 out of 16 minus 1 out of 4. When you do this, the final answer will actually be 3 divided by what? By 16. So it means when you integrate from 0 to pi out of 4, cos cubed of x sine of x with respect to x, you get 3 out of 16, and that becomes our answer. So honestly speaking, you realize this is not something really hard. Now from this level, I am going to give you a few questions that you can try out for practice purposes, and then in our next tutorial we shall add on, we shall look at mainly the UNEB past paper questions that need us to always change limits for more conveniency. Now, is it a must that we have to always change limits? It may not be necessarily a must, but it is more convenient because you save time. Just like you see in these cases, you would not substitute u in terms of x again because you already changed the limits. So let's take that seriously. So let me give you some trial questions for you to try out here. Trial questions, I will call it a simple exercise. I will call it a simple exercise. So you're going to try and evaluate for me the following integrals. Of course, if you get any challenge, just follow the previous video of change of variables, get the knowledge, then you can proceed here and move on smoothly. So evaluate the following integrals. Evaluate the following. Evaluate the following. Part A, we shall have integral from 0 to a half x out of square root of 1 minus x squared with respect to x. Part B shall have integral from 0 to 4 2x square root of 4 minus x with respect to x. Part C shall have integral from 0 to 4 I beg your pardon, here it should be integral from -1 to 0. Integral from -1 to 0. This is x into x squared minus 1, all this power 4 with respect to x. Part D. Part D, we have integral from -1 to 2 of x plus 1 into brackets 2 minus x 2 minus x. All this is power 4 with respect to x. And then part E, integral of sec power 4. This is from 0 to pi out of 6 first. We shall have sec power 4 x tan of x dx. Yes, I think we can try out these few questions, and then you can also refer to any of the Pure Math textbooks for more of them. Thank you very much. I'll see you again in our next tutorial, but please make sure, if you have not subscribed, consider subscribing so that you always keep receiving notifications whenever I load a new video. Also, try and share this video out there with our friends so that we can make this useful to our country and the world at large. Thank you so much. Bye bye.